start off our neural network. And we're going to compute, I'll write it in sort of Julia-like or MATLAB-like notation, for I equals 1 through n, I will update x by taking some function of my current input, maybe something like this. And what function h to use, I don't really care too much. In the old days, people used to talk about the sigmoid function. Nowadays, it's the maximum of 0 and t that gets used all the time. It's got this ridiculous name, ReLU, which I really can't stand. But anyway, the rectified linear unit. But in any event, I mean, it's just the function that's, you know, t if t is greater than or equal to 0, 0 if not. But whatever function and you like. And here, I'm just going to update. Okay, and then ultimately, you might also have some data y. And you would like to, if everything's a scalar, and like I said, this could be generalized pretty quickly. But what we can do is we can minimize, say, 1/2 y minus xn squared. You know, and you're going to want to find the data that would minimize that. Okay, and all this generalizes to matrices and vectors, which is what most neural nets do. Okay, and since I'm not going to have a lot of time, maybe I can just sort of cut to the chase. If I were to differentiate the key line here, got a little bit of Julia here, but if I were to differentiate the key line, what would I write? I would write, well, here, actually, let me use the usual notation. Let me have delta I be the h prime of wxi plus bi. Okay, so that's delta I. And then you can see that dxi plus 1 is delta